A star 25 times the mass of our Sun. Just disappeared. No explosion. No warning. No debris. One day it was there burning at 2.5 million times the brightness of our Sun, and then, nothing. The sky where it lived went dark. By the end of this video, you're going to understand exactly what happened in the Kinman Dwarf Galaxy 75 million light-years away, and why the answer astronomers landed on is somehow more unsettling than the disappearance itself. Let's set the scene. For over 2 decades, astronomers studying a small, irregular galaxy called the Kinman Dwarf, also known as PHL 293b, had been tracking a single, extraordinary star. It was what's called a luminous blue variable. Think of it as the universe's most unstable overachiever. These are massive, volatile stars that burn so hot and so bright they're constantly on the verge of tearing themselves apart. This particular star was so luminous it could be detected from 75 million light-years away using ground-based telescopes. That's not a typo. 75 million light-years. The light you'd be seeing left that star before the dinosaurs even existed on Earth. Scientists weren't just casually glancing at it, either. It had a signature, a specific chemical fingerprint in its light spectrum, hydrogen emission lines that were as recognizable as a face. Year after year, observation after observation, that signature showed up. And then, between 2011 and 2019, it didn't. Researchers from the University of Dublin pointed their instruments at the Kinman Dwarf, expecting the same familiar signal. What they got instead was silence. The star's signature was gone. Not faded. Not dimmed. Gone. They checked their equipment. They checked their data. They ran the observations again. The star had vanished. Here's where this gets complicated. Because in astronomy, there are rules. There are known ways stars die, and none of them are quiet. A star 25 times the mass of our Sun doesn't just clock out. When massive stars reach the end of their lives, they explode. We call it a supernova. It's one of the most violent events in the known universe, a detonation so powerful it can briefly outshine an entire galaxy of hundreds of billions of stars. We can see supernovae from billions of light-years away. They're hard to miss. But here's the problem. There was no supernova. No gamma-ray burst. No shockwave of expanding debris. No neutron star left behind. No nothing. Astronomers scoured the data optical telescopes, archival Hubble images, every available instrument, and found zero evidence of a conventional stellar death. For a star that massive to simply vanish without an explosion is, by the physics we understand, essentially impossible. So what happened? But before we get to that, you need to understand something even stranger about the kind of star this was, because luminous blue variables don't just disappear. Sometimes, right before they die, they do something that makes them look like they already have. Luminous blue variables are drama. They go through eruption phases, periods where they eject massive shells of gas and dust, so thick that the star effectively wraps itself in a cocoon. From the outside, looking in, the star can seem to dim dramatically. Its light gets swallowed by its own outburst. The lead researcher on the 2020 study, Dr. Andrew Allen, considered this. What if the star hadn't died at all? What if it had simply entered an extreme eruptive phase, throwing out so much material that it cloaked itself from our instruments? It was a reasonable hypothesis. It would mean the star was still out there, hiding behind a veil of its own making, waiting to re-emerge. They modeled it. They ran the numbers. And the numbers didn't work. The dimming would need to be so extreme, the dust shell so impossibly dense, that it strained credibility beyond what physics comfortably allows for even the most violent known eruptions. Which brought them, reluctantly, to the other answer. The answer that changed the conversation entirely. The star didn't explode. It collapsed, directly into a black hole. No supernova. No last cry of light. It simply crossed a threshold, the gravity of its own dying core overwhelming everything, and in what may have been a matter of seconds on cosmic timescales, an entire star 25 times the mass of our Sun ceased to exist as light-emitting matter. This is called a failed supernova. And while theorists had predicted it could happen, this was the first observational evidence, real, documented, peer-reviewed, that it actually does. A star simply switching off. The ultimate disappearing act performed by the universe's most extreme objects. Think about what that means for a moment. We've always defined black holes by their effects, the gravitational lensing, the accretion disks, the jets of energy. We've never watched one be born in real time. Until, possibly now. The star in the Kinman Dwarf didn't fade. It didn't explode. One moment it was blazing across 75 million light-years of space, bright enough for our instruments to taste its chemistry. And in the next window of observation, a cosmic blink of just a few years, it was a hole in the fabric of space. Here's what this does to astronomy. For decades, our models of stellar evolution, our understanding of how massive stars die, assumed the supernova was essentially mandatory for the most massive objects. It was the mechanism through which stars returned their material to the universe. Supernovae seed galaxies with heavy elements. They trigger the formation of new stars. They are, in a very real sense, the recycling system of the cosmos. But if massive stars can collapse silently, vanishing without seeding anything, then our accounting is wrong. The universe may be producing far more black holes than we've calculated. And far fewer of those critical heavy elements may be making it back into the star-forming regions where new suns, new planets, and potentially new life emerge. The disappearance of one star in a dwarf galaxy 75 million light-years away might quietly be telling us that the universe is darker and stranger than our best models assumed. There's a star-shaped hole in a galaxy you'll never visit, created by a collapse you'll never witness, producing a black hole that emits no light whatsoever. And the only reason we know any of this is because someone noticed an absence. A missing signal in a sea of data. A silence where there used to be fire. The universe doesn't always announce its most radical transformations. Sometimes it just stops answering. And all we can do is keep watching the dark and wonder what else has quietly disappeared while we weren't looking. If this broke your brain a little, subscribe. We drop one of these every week. Next time, the Boötes void, a region of space so empty, so vast, and so perfectly structured that some physicists think it shouldn't exist at all.